Hello everyone, welcome back to my podcast Think Tech. In today's episode, we'll talk about three key concepts that play crucial roles in building robust and efficient distributed systems, that is reliability, scalability, and maintainability. Understanding these concepts is essential for designing and managing distributed computing systems that can handle increasing workloads, remain operational in the face of failures, and be easily maintained and updated. In this podcast, I have explored each concept individually, providing relatable examples and explanations in very simple terms. Let's get started. First, let's talk about reliability. In our digital world, we often use distributed computing systems to do things like accessing files in a cloud or processing massive amounts of data. But have you ever wondered how these systems ensure that they work reliably? That's what we are going to explore. So, when we talk about reliability in distributed computing, we mean the ability of a system to consistently deliver the expected results, even when things go wrong. It's all about making sure that the system keeps running smoothly no matter what challenges it faces. Imagine you are working on a team project that involves processing a huge amount of data. Instead of relying on just one computer, you decide to split the work among several machines to speed things up. But what happens if one of those machines crashes or loses power? It could really mess up the whole project. Reliability is all about setting up the system in a way that prevents such failures from causing major disruptions. It means designing the distributed system in a clever way so that it can keep doing its job even if some of the parts are not working or stop working. Okay, so how do we make sure that a distributed computing system remains reliable? There are a couple of techniques we can use: redundancy and fault tolerance. Let's understand them in detail. Redundancy means having backup plans or duplicates of important components in the system. It's like having spare parts ready to replace the ones that break. Think about when you're streaming a movie online. Instead of relying on just one server to send you the movie, the system might have multiple servers hosting the same movie. If one server has a problem, no worries, the system can smoothly switch to another server. So you can keep watching the movie without any annoying interruptions. Now, fault tolerance is about designing the system to handle failures gracefully. It's like having a safety net that catches you when you fall. Let's say you are shopping online. When you add items to your cart and proceed to checkout, your order information goes through multiple servers that work together. Now, if one of those servers suddenly has an error, a fault tolerant system would notice this problem and send your request to another server. That way, your order gets processed smoothly and you don't even have to worry about the glitch that happened behind the scenes. So basically, reliability is super important in the world of distributed computing. It's what makes sure that these systems keep running smoothly even when things don't go as planned. And by using techniques like redundancy and fault tolerance, distributed systems can handle failures and keep providing us with uninterrupted services. So whether you are accessing cloud storage, you are using online apps, or just relying on distributed computing for big data processing, reliability let us trust these systems to work reliably. And as technology keeps evolving, maintaining reliability will always be a top priority in building robust and dependable distributed computing systems. So next time when you're enjoying a seamless online experience, you'll know that reliability is a magic that keeps it all going. Next, let's talk about scalability in distributed computing. Scalability in distributed computing refers to the system's ability to efficiently handle a growing amount of work, users, or data. It's all about being able to accommodate more and more demand without sacrificing performance or becoming overwhelmed. To better understand scalability, let us imagine that you have a bakery that has been doing very well. However, as word spreads about your delicious pastries, more and more customers starts coming in. Now, to ensure your business can keep up with the increasing demand, you need to scale your operations. Scaling can involve various aspects, such as adding more baking stations, hiring additional staff, or expanding your kitchen space. The goal is to handle more customers efficiently without compromising the quality of your baked goods or making customers wait too long. When it comes to achieving scalability in distributed computing, we often employ two approaches. First, vertical scalability, and second, horizontal scalability. Let's break them down. Vertical scaling is also known as scaling up. It involves improving the performance of individual components in the system. It's like giving your bakery a boost by upgrading your equipment. Imagine you have a single oven in your bakery, but as demand increases, it starts to take longer to bake all the pastries. To vertically scale your bakery, you might decide to replace the existing oven with a larger, more powerful one. This upgrade allows you to bake more pastries at once, reducing the time it takes to meet the customer demand. On the other hand, horizontal scaling, also known as scaling out, involves adding more components or resources to the system. So, continuing with the bakery analogy, let's say you have reached the capacity of your kitchen and upgrading the existing equipment won't suffice. Instead, you decide to open a new branch in another neighborhood, and by doing so, you distribute the workload between multiple locations, allowing you to serve more customers without overcrowding the original bakery. So, scalability is a vital aspect of distributed systems, which enables them to handle increasing workload, users, or data without buckling under the pressure or experiencing sluggish performance or crashes. Just like a bakery that scales up or opens new branches to growing demand, distributed systems scale vertically or horizontally to maintain optimal performance. As technology advances and our digital needs grow, scalability will continue to play a crucial role in building robust and adaptable distributed computing systems. So next time, whenever you enjoy a smooth online experience during peak hours, remember that scalability is the magic that allows these systems to expand and cater to our ever-increasing demands. And finally, let's talk about maintainability. Ensuring smooth and reliable operation is only half the battle. Another very critical aspect is maintainability. Maintainability focuses on the system's ability to be easily managed, updated, and repaired over its entire lifespan. So let's understand what maintainability is. Maintainability in distributed computing refers to designing and managing systems in a way that simplifies maintenance, simplifies troubleshooting, and simplifies updates. It's all about making sure that the system remains manageable and can adapt to changes without causing unnecessary downtime or disruptions. To help illustrate maintainability, let's imagine you have a car. Just like any other machine, your car requires regular maintenance to keep it running smoothly. You change the oil, you replace worn out tires, and perform routine inspections to catch any potential issues before they become major problems. In distributed computing, maintainability is about implementing practices and designing systems in a manner that make it easy to identify and address issues promptly, update software or hardware components, and ensure overall system health. In my opinion, to achieve maintainability in distributed computing systems, only two essential aspects come into play: modularity and documentation. Let's take a closer look at these concepts. Modularity involves breaking down the system into smaller, independent components or modules like microservices. Each module has a specific function and can be managed and updated separately. It's like building with Lego blocks, where you can modify or replace individual blocks without affecting the entire structure. For instance, imagine you have a home entertainment system consisting of a TV, a sound system, and a streaming device. If the sound system malfunctions, a modular setup allows you to replace or repair just that component without affecting the rest of the systems. This modular approach in distributed computing simplifies troubleshooting and updates, making it easier to maintain the system. Next is something I have personally experienced to work wonders when it comes to efficiently maintaining a code base, that is documentation. Documentation is all about providing clear and comprehensive instructions, guidelines, and explanations about the system. It's like having a detailed user manual of your car that helps you understand how everything works and guides you through maintenance tasks. In distributed computing, proper documentation ensures that administrators and technicians can easily understand the system's architecture, configurations, and protocols. This documentation makes it easier to diagnose problems, apply updates, and overall manage the system effectively. However, one problem with documentation is that it becomes pretty outdated pretty quickly. Therefore, it is the responsibility of the developers to ensure that in whatever manner they prefer to write their documentation, it is always up to date and reflect the current and accurate state of the system. So to sum it up, maintainability is a critical aspect of distributed computing systems, ensuring they can be easily managed, updated, and repaired over time. By embracing modularity, breaking down the system into manageable components, and providing comprehensive documentation, we simplify the maintenance process and reduce the chances of downtime or disruptions. So, in conclusion, reliability, scalability, and maintainability form the foundation of successful distributed computing systems. Reliability ensures consistent and uninterrupted performance, even in the face of failures or disruptions. Scalability allows the system to efficiently handle growing workloads, users, and data without sacrificing the performance or becoming overwhelmed. And maintainability simplifies system management, troubleshooting, and updates, ensuring long-term efficiency and adaptability. By embracing these concepts, we can build distributed computing systems that provide seamless experiences, handle increased demands, and remain manageable and up to date over time. And as technology continues to advance, these principles will remain essential in shaping the future of distributed computing and empowering us to leverage its full potential. And this brings us to the end of our discussion. Thank you so much for listening to this podcast. I hope you found it helpful and informative. Thank you.